can go.
Okay, good morning, everybody. Welcome to our 2015 edition of our dress rehearsal, which is our run-through of our National Chemistry Week program for the Cleveland section of ACS. There's several housekeeping items that I'd like to go through with you first. In your packets, when you get to the libraries, but even before that, beg your pardon, I'd like to introduce myself. I'm Bob Fowler. I have a couple of members of our planning committee with me. Vince Opaskar, who is going to help me, and Mike Nichols is an unofficial member of our committee. I'd like to thank Dr. Nichols and Dr. Wayner Riley and John Carroll University for the facilities, for the use of the facilities here. Wonderful that you guys do this for us every year. Okay, let's jump into the program. A couple of things to call your attention to. First thing is that on our website, and you will have an indication of the website URL in the script that will be in your kits, there's an errata sheet in there. These aren't big deals, but I would call your attention to the errata sheet and suggest that you look at that and make those appropriate changes in your text of the script as you go through it. In the actual kits that you're going to have, along with the materials for all the experiments, are several things. There's a demonstrator feedback form. There's just one of these. And if you would fill that out at the end of the program and turn it into us, I really appreciate it. The instructions, again, are in the text that you'll be given. There are also photo consent forms. The libraries, at the Cuyahoga County libraries at least, will tend to have their own, but if you want to take pictures, make sure that the parents sign these photo consent forms before you do so. It isn't mandatory that you take pictures, but if you care to, please fill out those forms, have the parents fill out those forms. There's a student feedback form. At the end of the day, and I'll try to remember to mention this again at the end of this day, but at the end of the day, please ask the students, the kids at the program, to please fill out this form and return this to us. We don't want anything else returned except the two feedback forms and the photo consent forms if you use them. There's also a handout that you can give to all of the kids. It's just a little fun thing we came up with about color. Color is our theme this year. As a matter of fact, Chemistry Colors Our World is the actual theme. There's also copies of Celebrating Chemistry that we got from ACS National. All those things are in your packet. Each of the students could take a copy of the Celebrating Chemistry home with them, as well as this to fool around with at home. And if you have any of these forms left over or the Celebrating Chemistry, please give them to the children's librarian at the library you're going to be going to, and they will then distribute them to other kids as they come in. Okay, let's get started with the program. I've given you a copy of the experiments. We have 6 experiments this year, and again, the theme this year is Chemistry Colors Our World. And to that end, we have 6 colorful experiments. These are always fun to pick out every year. And by the way, I thank Vince Opaskar here for really coming through with a lot of ideas for the colorful experiments for this year. As we go through the experiments, there is a little roadmap that I put together. This is on page 16 of your script. Those of you who are watching on YouTube, you guys here at John Carroll don't have a copy of the script, although there were a few over here. There's a copy of the script in with each kit, okay? What we're doing this year is we have several experiments. Of the 6, there are like 3 of them that require things to dry, to spread out in a chromatography experiment we have, and so forth. They require some time after the initial setup. We're going to be jumping back and forth between the 6 experiments. This little roadmap on page 16 of the script will actually help you, and I suggest that you have page 16 from your script open as you're going through the program and use this roadmap. It says, number 1, start with experiment 1. And I think what we're going to do is we're going to go ahead and get started with experiment number 1. It's called glowing chalk. Vince is going to present experiment number 1. I'll present 2, 3, and 4, and then Vince will jump back in and present 5 and 6. So Vince, if you would, with experiment number 1.
Okay, Bob has a good outline. This is another idea I came up with that was doing some painting in the house, boxing stuff up, and have the boxes left over. So if you have an assistant, you can have them take a magic marker and just proceed through the agenda, just cross them off, so the kids know where they're at and how fast we gotta move, because this may take a little longer than an hour. It all depends. Okay, so the first experiment is going to be kind of a smattering of a lot of different things that are being put together for one little project. And it's the materials that you should have in front of you. We should start with a plain blank piece of paper that's cut in half. It's an 8.5 by 11. So if you could take that. And we're going to create a mold for this canister that you should have. And what I'm going to do is fold the piece of paper in half, as you should. Take the top off the canister. Curl the piece of paper around your finger so that you can fit it into the canister. Okay?
And then do you have it fold side up or fold side down, or does it even matter?
Doesn't make a difference. Okay. All right, forget the cap. Now we're going to get into this 1 cup labeled C, which is a glow-in-the-dark pigment. It's going to be active. As we know, color is all wavelengths of light or lack of wavelengths of light. That's too much to understand for the kids at this young age, but you know that it's not radioactive and it will glow in the dark. So we're going to take some plaster of Paris, which is in the tall stir, tall graduated cylinder. Should be about 40 to 45 cc's. There's been some settling of this material over the last several weeks, but it's regular plaster of Paris. Okay.
Yeah, I know. I spent a lot of time on this one.
So what we're going to do is we're going to take all the plaster of Paris and add it to the cup with C on it. Tap it. A little stubborn from having sat all that period of time. Okay. Okay, then we're going to take approximately 20 cc's. It's
So
not
you want to
marked.
stir first to mix the
Well,
powder?
we're going to use the stir,
Okay.
mix it up. So we get an even, uniform distribution of the pigment, which incidentally came from Dayglow here in Cleveland. Now, here comes the tricky part. You're going to add water to this mixture, just to the point where we don't want to add too much, because it's going to take too long to dry. So we want to get it to the consistency of ketchup. So let's start with a little bit of water. Let's mix it up. Now at this point, after you make your first addition, and don't be generous, be stingy. Get it good and stirred up. Now, if you find that you need a little bit more water, what I would suggest is going to another one of the experiments in which we use a pipette.
They're right, they're right.
Right here. And add drop by drop or just a little bit at a time. If it's too stiff, just add a few drops because it's not going to take a lot of water to disperse it. Is everybody caught up? Got your ketchup ready? What we're going to do now is we're going to pour it into our mold that we created a few minutes ago. And we should be able to pour it and let it drop in. Using the stirrer, we're going to fill it up as best we can with most of the material. You might want to have one of the students hold the canister steady while it's being filled up. It's kind of hard to do by an individual. Then you want to take your canister, tap it down so that there's no air pockets left. Okay, so I should be hearing a lot of tapping pretty soon. We're going to let this set, and we're going to go back to my little chart on the wall, and then we're going to check it after our third experiment. That should take us about 20 minutes into the presentation today. Then we're going to strip off the paper at the end, and we're going to let it absorb energy from the lights. And at the end of this performance, we're going to turn off the lights and we're going to look for our glow-in-the-dark chalk. Now the kids can take this home. It's one of the few things that we allow to go home. And at night, they can put it on the sidewalks around the house. And then you got to let it go for a day to absorb the sun's energy. That's going to show the light. And then when it gets dark on the second day, you will see whatever you have written on the sidewalk. Okay?
And will the paper peel right off?
It will.
You will see.
This is awesome. Kids are, yeah, this is cool.
We're using stuff that you have hanging around at home,
Yeah.
and we're using it for good reason. Okay? So we're going to come back to that. And one other thing I wanted to mention. When you're reading through this introductory materials, they list the numbers or the names of paint companies in Cleveland, but they only mention Sherwin-Williams and Glidden, Dayglow, and RPM. But don't forget, look in the phone book and you'll see Benjamin Moore, PPG, Flood, Waterlocks, ICI, Cleveland Paint, and Euclid Paint Companies. So you might want to impress the kids with, there are plenty of opportunities for paint chemists. In fact, my assistant that's going to be working with me is a retiree of a company that made pigments for his whole career. So there's plenty of employment opportunities. You might want to keep throwing these little tidbits of information to the parents that are in the background a lot of times at the presentations, and encourage them to take up chemistry. Okay, we'll come back.
Something I like to do when I'm doing the demos is take a couple of brown paper lunch bags and tape them to the end of the tables where kids are working so that this could just right in the trash, and then you can grab those at the end.
That's a real good idea. We did that several years ago when we were doing the behind the scenes thing, and we had Q-tips all over the place.
Right.
And that's a real good idea. Take some just regular brown lunch bags
And just
and
scotch
tape them
tape
to the tables if you care to, and they can use that for little disposal areas.
Otherwise, they'll keep fiddling with this.
They will, and they'll spill things, and that's not
Yeah.
a good thing. Okay, everybody got their their chalk well on its way? Let's move to experiment 2, which is experiments with dyes. We have several dyes we're going to be looking at today. And as you go through these things, you might want to use the script a little bit to talk to the kids about the various aspects of chemistry and color and so forth. And you might mention that we as a species have been using dyes really since the days of the caveman. And where do these things come from? Usually just the environment, plants, leaves, lichens, and that sort of thing. You get pigments and then dyes from the pigments. And of course these days, Vince just mentioned, there are all kinds of modern companies that make their own pigments, organic and inorganic, and dyes and paints from that. But right now we're going to be concerned with dyes. What we hopefully are going to have in the library setup is 5 tables with 5 student children at each one of the tables. At this point with this experiment number 2, and by the way, I recommend that you continue to follow this sequence of events as we go through it. With experiment number 2, we're going to go to each of the 5 tables and ask the 5 students there to get a number, 1 to 5. So since we don't have 5 people at all the tables, let me ask you folks at this table right here to start with 1, 2, 3, 4. Why don't you be number 5? Why don't you start with number 1 for the second table, 2, 3, 4, 5 back there, okay? And what we're going to do is person number 1 at each table. If you look in the middle of the table, there are pieces of fabric. They're just these little guys right here. And note that each piece of fabric has a dotted line or a black line over on the left. Okay? We consider that the left of the piece, and there are in fact 13 different pieces of fabric on this one section. So if the person number 1 at each table would please pick up one of those pieces of fabric and bring them up here. I'm going to ask people number 1 to simply take their piece of fabric and put it in the cup, marked here as cup D1. Put it in there, just let her go. And if you put yours in there and return back to your places, please. And as the demonstrator, if you would take the fork that's in front of each one of the cups as the pieces of fabric go in and swish them around a little bit to make sure that all the pieces of fabric are being exposed to the dye. Hopefully you're going to have 5 pieces of fabric in each cup if you have a full complement of 25 children at these demonstrations. Okay, person number 2 at each table, please bring up a piece of fabric and put it in cup D2. The reason why we don't have these cups, thank you, drop it right in there. The reason why we don't have these cups at each of the tables, hopefully is obvious. These are real simple dyes. That's Kool-Aid, this is a food color, and then Rit dyes. But as you know, they can stain their clothes if the kids would drop them on there, and that's exactly what's going to happen if we allow the kids to have these at their own tables. So we're trying to keep control over it at the demonstrators table, and we have this tray. If we have any spills, hopefully the tray will contain the spills. Okay, person number 3 at each table, if you please bring your piece of fabric up. And we've got a fork and a paper towel in front of each one of these. Swish those around real good. And person number 4, please, at each table. Okay, and we'll squish these around a little bit. We're going to find out in a little bit that the only difference between D3 and D4, they're both RIT dyes, is the RIT dyes available commercially. I got ours, I think, at Giant Eagle. No plug intended. There's a little bit of vinegar in with this. The vinegar presumably is going to, possibly at least, enhance the dyeing capability of the RIT dye. Okay, look on your sheet, on your sequence of experimental events. This will be page 16 in the script. We're going now to, that's part 1 of experiment 2. Obviously, those things need to soak a little bit to allow the fabrics to, the dyes to penetrate the fabrics. We're going to move to experiment 3 now after completing part 1 of number 2. And experiment 3 is all about indicators. It turns out that during the medieval times, people used to use a certain flour in France to stain things. And after they had dyed fabric with this flour, depending upon the color, or depending upon what they would wet the fabric in, it turns out there'd be different colors on that fabric. If it was an acidic kind of material that they would soak it in, it would turn red. If it was more basic, it would turn blue, and other colors in between. So what we're going to do is we're going to use a modern approach, somewhat similar to that, and at this point explain the notion of pH to the kids, because that is exactly what's affecting these colors of these fabrics as they wet them with various materials. And to that end, each of you has in front of you 4 pieces of pH paper. So locate those, please. A paper towel and 4 Q-tips. If you would please take the paper towel and you would put it long ways, across if you would, cross you, and lay your 4 pieces of pH paper on that piece of paper towel. Separately, yes. Separate them a little bit so that no one thing is going to affect the other. At the front of each table, there are 4 cups marked 1, 2, 3, and 4. Person number 1, please take cup number 1, and not yet, jump of the gun. Person number 1, please take one of the cup number 1, and take your Q-tip, one of the Q-tips, dip it in there, don't get it too awfully wet, and touch the end of your first piece of pH paper. Okay, pass cup number 1 down. And you can pass the Q-tip down if you like. And person number 2, please do the same thing. Okay, if person number 1 could now take cup number 2 and repeat the process. And so forth through cup number 4. Okay, we'll give you a second to finish that. By the way, I'm wearing the plastic gloves that came with the kit because I've been handling the dyes up here, okay? I'm not one who likes to wear plastic gloves for too long, so I'm going to remove these now. I can't even turn the pages of the script with these plastic gloves on. That's something you might want to note. Okay, how are we doing with that? What cup number are we at? We're on 4? Okay.
2 bases, 1 acid, and 1 more or less neutral.
You got it. Okay, cup number 1 had vinegar in it. Cup number 2 had just plain water. Number 3 had some baking soda, and 4 had some borax. Let's see what kind of pHs you're getting. Okay? There's 4 index cards there. 4 index cards that have numbers 1 to 5 on them. Okay? So what we'd like for you to do is, okay, write down, if you would, on the card, the pH of the first 4 things. There's a color scale, I beg your pardon, there's a color scale, it's supposed to be a color scale, up on the front of each table. So if you'd pass that down, please, and please compare your colors on your pH paper with the color scale, and write those down on the card, and then pass the pH scale down, please. Give you a second to do that.
What's it got to?
Number 2 was just tap water. So it should be 7 or maybe a little bit higher.
I actually think that 3 had the tap.
reversed.
3
Yeah.
has the tap water
2
in
and
it.
3 are reversed, I think.
Yeah.
2 and 3 reversed? Okay.
Yeah, 3 has the tap water in it.
Okay. It doesn't really matter. What we're really interested in is what pHs are you finding?
According
I'm told Cleveland tap water is treated with various reagents. It gives it typically a pH higher than 7. How we doing, guys? Simple experiment, but it still is a little bit colorful, if you would, and it demonstrates the principle that we were talking about with the flour and then the material from the flour staining, dyeing fabrics in the Middle Ages, and then turning different colors depending upon what it was immersed in, basic, acidic, or something closer to neutral. So same basic concept. How we doing? Everybody got their pHs?
Might want to mention, and everybody might want to mention that these are pieces of litmus paper, and it's got a special chemical added to the ordinary piece of paper to give it color. And this color of that chemical is changed when you put in the other liquids, and it rearranges the molecules. We'll introduce a big word here, and changes how the light goes to the piece of paper and allows certain colors of the white light to be separated and give you a different color in each case.
Okay, we'll leave that up to the discretion of the demonstrators, what they think the 3rd to 6th grade kids can really understand and comprehend. Okay, let's see what we got. What kind of pH do we have for number 1? Hi-oh. Hi, gang.
1.
What'd you get?
I got 1.
You got a pH of 1?
Yeah.
Definitely acidic, right? How about number 2? 8?
8. 8.
Okay, so we can see what happens back in the Middle Ages when we treated that fabric with something acidic or something basic. How about number 3?
5 or 6.
That's 6.
5 or 6? I think that must be the water, it's a little bit low on pH today. And the number 4? 9 or 10, again, something pretty basic, okay? There is, in fact, the chemical that Vince was talking about in the litmus paper actually refers to a Norwegian word to color, and that's the reagent or the chemical that the litmus paper is treated with, okay? So a simple little experiment, just you can talk about pH if you care to. You can talk about the other materials that are in the script having to do with the fabrics and the dyeing back in the old days and so forth, and how things would react and change color depending upon whether they were immersed in a basic or an acidic or a neutral solution. Okay? All right, now let's move on to one that should be a lot of fun. Yes?
You know, sometimes the pipes have lead in them. that affect the pH levels too?
Let me ask a chemist.
Not significantly.
Okay. I'm an engineer, by the way. You know,
But
we
but
chemists
acidic-
don't know any chemistry.
But acidic water will extract that lead.
It will?
Yeah.
Yeah.
But it won't change the pH that much, right?
No.
The lead?
No.
Okay.
The water itself, the pH in the water itself will be extracting the lead.
Okay.
If you have lead pipes, old lead pipes, there'll be scale on the inside that'll protect the lead from the water. So,
Leach out as well.
well, it won't leach out as quickly if there's scale built up on the inside of the pipes. If the water becomes acidic, it'll remove that scale and eventually it'll leach more lead.
Okay.
But in the basic water that we have here, it probably isn't gonna be, the lead's gonna, it's gonna be in an older situation where the scale's been removed.
Okay. Now we're going to move into our patriotic area. First thing we're going to do is we're going to talk about how things.
Is that hearing ink next?
Yeah. Yeah.
Okay.
We're talking about patriotic kinds of things, okay? And the first thing we're going to talk about is what used to happen back in the days of George Washington. There was an interesting program on TV, a series called Turn, T-U-R-N. I don't know if any of you folks have seen it, but in that series, they were sending secret messages, Washington's spies. It's all about George Washington's spies. And back in the Revolutionary War days, what they were doing was they were sending secret messages right under the noses of the British, and sometimes the British weren't even aware if they had intercepted one of these things, that there was a message written on a piece of paper because the colonialists used disappearing ink. Well, in front of each of you there is an index card with a Q-tip on it, and there's a little cup marked B. We have written a message on the blank side of the index card, and what the students are going to do, no, you can't see it now. See, you're one of the British. You're one of the Brits trying to see whether or not there's George Washington's spies has a secret message on there. What we're going to do is we're going to use the plain side of the index cards, okay? Not the ruled side. And we're going to use the material in the cup marked B, and you're going to put your Q-tip in that, and you're going to paint the surface. Don't use too much liquid, okay? Because it might tend to blur out what's written on the card. But use your liquid in the cup marked B and paint the surface of the card and see if you can come up with what the message is. I sure hope this works.
We didn't get any liquid in our bee.
You get any liquid in your bee?
None of them.
No bee in your bonnet? Here, I got you one up here. Here you go. How we doing? Anything appearing?
Something pink.
Bobby didn't get anything.
I had a little bit of pink.
I got the 2,000 to the 20.
Ah, you got the
2,000.
20. Okay. Can anybody tell what you've gotten? Can you tell what that is?
Maybe a 17.
Maybe a big W.
Oh, yeah, it is a W.
It's a big W. Did you get anything? There you go. I think you need to use more liquid. Okay, I'm hearing somebody had a 20. Okay. Somebody had a big W. Somebody had a big C. Anybody else have anything?
Big N.
15.
15? Okay. What is that? That's nothing. You have an N. Okay. Well, guys, we have, let's see if you guys can figure out what the secret message is.
He is.
We have a W.
National Chemistry 2015.
Bingo! Somebody figured it out already. Now, how is that for imagination to come up with a secret message to put on the cards? Yeah, what you've got is you've got 5, or what the kids will have is 5 different cards. Some of them have, and they're written in big letters. Some have a big N on them, a big C, a big W, and then the last of the 5 have a 20 and a 15. So what the kids are gonna have to do is they're gonna have to work together to come up with what the secret message is. And they aren't going to be as familiar with the program as you are, so they're gonna be wondering, what is the secret message? So you might have to help them out a little bit as you get to it, to actually decipher what the message is. Did it work pretty well? Can you see letters well enough?
You need to use more liquid, be cautious not to use too much, but
Yeah.
actually you need more.
Ah, okay. Did you hear what Bob just said?
I didn't know.
For those of you watching on
I
YouTube,
agree with Bob.
Bob said you need to use more of the liquid. That's just a borax solution in that cup marked B. You need to use more as opposed to less.
It also fades as it dries.
Yeah.
Yes, it will fade. And we were concerned that it might smear a little bit too. That's why I cautioned you to use air on the less fluid side. But apparently it works better if you use more of the liquid.
And what is it, phenolphthalein on the?
Yeah, it's just phenolphthalein.
The message?
Phenolphthalein, and the secret message, of course, is NCW 2015, which is what we're doing. How'd you like that, Haley? Is that cool? See, you're just like George Washington's spies, and that's how they would deliver messages, and the nasty old Brits wouldn't even know that they had a secret message being delivered. Okay? Alrighty. We're going to move on to experiment number 4. Well, that was experiment number 4, I beg your pardon, appearing ink. Now we're going to move to another one of our patriotic experiments, colorful patriotic experiments. It's actually called Patriotic Colors. And at this point, I'm going to turn it back over to Vince. And Vince, this is your thing.
Okay, before we go into number 5, let's see if we can pull our plug out of,
Excuse me, Vince, if you do that, you're not following what this thing says.
I know.
Okay? It says to go to experiment 5 next, but whatever.
whatever.
Go for it.
Okay. Tap your filling, see if it's starting to set. If it's starting to set, we can pull it out. Okay? Just don't take the paper off yet, because we're gonna let this dry a little bit more, okay? So we can peel off the paper later on, all right? So
Now,
we'll just set that on.
Now to break the seal at the bottom.
Right, okay.
Before it gets too hard, you can't do anything with it, right?
Yeah.
So we'll come back to that in a few minutes.
Okay.
All right, the
Very
next
nice.
experiment is gonna use a large portion of all of these vials that you have set up in front of you. We're actually gonna make 3 colors. We're going to do actually 4 experiments, and it gets a bit confusing, so we're gonna have to keep the numbers straight.
They're in sequence, that should help.
Are in sequence. And I'm gonna turn them around so I can actually see. Okay, we should have, first one, we're doing red.
It's vials number 5 through 11. Of all of those big vials on the front of each table, vials 5 through 11 are the ones that Vince is going to be using.
All right. Bob, you know this a little bit more than I do. All right. Program. Okay. Well, we start with the one, I need another page. If I knew what was in the bottles, it'd be done
We're
in
going
2
to start
seconds.
with 8, 9, and 10.
8, 9, and 10.
Okay? So someone grab vials number 8, 9, and 10 at each table.
Okay.
Then you're gonna get a pipette. There's pipettes, plenty of pipettes there. You're going to fill it
Number 8.
with a solution marked 9 and empty it into 8.
Okay. Take the film off.
Remove the parafilm.
Okay,
You're gonna take about 3 mils into your pipette of of the vial marked number 9.
number 9.
And empty it into the 50 mil vial marked number 8.
Okay, when you do that, make sure we don't spill these things. We might want to have one student hold the vial, one student to pipette the second material into it. And I would do it drop at a time. That first drop is very dramatic.
Oh, you already squirted all yours in. What color are you getting?
Red.
Aha,
Okay?
patriotic colors.
Second and
Now
a
put it
third
in,
drop
Drop at a time.
keeps getting darker. Okay, we're using a potassium thiocyanide, if I'm not mistaken,
Yes.
into a iron, which is number 9.
There's some wooden stirring sticks there that you can use, or you can simply shake it.
Or you can simply shake it. You can see that we're getting deeper and deeper color because we're increasing the amount of of the product that we're actually making inside the flask, okay? Now, if you were to dry this, you'd get a really blood red, real dark red color. But we're not, we don't have time to do it.
Like 3 drops, not 3 milliliters.
3
No,
drops.
you can put the whole 3 mils in, but just
That's 3
drop at a
pipettes,
time.
isn't it?
Mhm.
Isn't that 3 pipettes?
No, no, no.
No, they hold about 3 mils.
They do hold about
Oh,
3
they
mils.
do? Okay.
Yeah, the pipettes hold about 3 mils. If you get the thiocyanate solution from 9 into the pipette and drip it into the other solution, you'll get that brick red precipitate starting to form. So that's the first of our 3 patriotic colors.
Okay, we'll save this.
And it gets darker red the more that you put in.
Okay, color number 2.
Now we're gonna use the vials 10 and 11.
Thank you, Bob. Same deal,
3 mils from 11,
but a fresh pipette.
fresh, oh, absolutely, fresh pipette.
No,
Yeah.
all the way, hold on. You gotta-
Okay, let's do 1 drop at a time, just like we did on the first one.
and then put it in, then the cup. And you fill it up.
We're going to drop by drop 3 mils of the solution from the vial mark 11 into the vial mark 10. So 11 into 10.
You don't see an immediate effect on this.
Okay, down it.
We're starting to see a little bit of cloudiness. Let's take a second pipette full.
You don't think the kids are gonna do it drop by drop?
No, I said I don't think it matters how much you put in the pipette.
Yeah, we're
You
just,
wanna, just fill it up and then put it in
we're
the-
exploring here.
Now we're gonna have you shake.
Okay.
Okay, I'm working on my 3rd pipette full, and I'm getting a white hazy material.
Right.
What happens when you hold it up against that piece of white paper?
Well, and if you shake it this way.
Ah.
Do you want to do another pipette in it? Make it whiter?
Okay, now, interestingly enough,
Yeah.
this white material,
Okay.
we're taking a calcium material and a carbonate
Cool.
material to make calcium carbonate, which we already saw today's experiment for the plaster. So that we're kind
Very
of
similar.
making a circle of chemistry materials. We're making some of the starting materials.
Not plaster, first was calcium sulfate.
Calcium, that's calcium carbonate, it's chalk.
It's close. That's one of the erratas in your sheet, by the way. It's errata number 1.
Hold it up against your black shirt. We can see it better. There we go.
Is it getting
Perfect.
cloudy?
It is,
Thank
but
you.
it's a little hard because of the, you can see,
Maybe this one, Vince, we should have them squirt the entire 3 mils in at the beginning,
we've put 2 pipettes worth,
okay?
Okay, let's go full out.
yeah.
Dump it in.
There you go. And put the whole thing in, open up 11.
Ours worked with 3.
There you go. At least you're getting the white precipitate now.
Yeah.
Yeah, I think it's just their vial is.
Well, we got like
less
a
cloudy,
layer and then
you know,
it got bigger and then we
Shake
shook
it.
it, so.
Okay, there you
You
go.
can tell it's white now.
But we're getting white, right? We got red, we got white. Guess what the 3rd color is going to be?
Third color.
Okay, again, I would emphasize that you have
There you go.
everybody cooperate in the group and hold these things so we don't have a lot of spillage. Okay? All right, so, the next one is a vial number 5, along with 6. Okay, so 5,
Open up 6.
It's right there.
Yeah, number,
6.
part number 3 involves vials 5, 6, and 7.
And 7.
5, 6, and 7.
So do that one first.
And again, a clean pipette. So we're gonna take 6 and add it to 5.
No, the other way around.
The other way, you wanna go? Okay.